Hi everyone, it's me again, Allen Everson Malabanan, and welcome to another edition of Allen Vlogs. As you can see, we're here again at NetAcad, Chapter 8, Subnetting IP Networks, and what are we going to do is we will answer all the activities that are given here in this chapter. So as you can see, I have already browsed all the given activities here in this chapter. So it has only three activities here. Well, I guess it will not be that long. So now first we're here at chapter 8.1.4.4, which is calculate the subnet mask, and basic, which is it is the basic, like easy or what. So let's start. Instructions in this activity. You are given a subnet mask. So this is subnet mask here, and in the decimal format. Is in decimal format, either the binary representation of the subnet mask in the octet fields provided. Enter the binary. So we have to enter the binary here, the binary equivalent of the subnet mask in decimal here. So additionally, convert the mask to prefix notation with this format in the prefix notation field. So it is the prefix notation field. So we were gonna enter the prefix notation that we will gonna convert from this binary. So let's start answering. So first, as you can see, we have 255 here and 255, 248 and 0. So when we're converting subnet mask and binary, all we have to do is uh, to sum all the binaries, like in the place of 1 2 4 8 16 and so on. Because we have 255 here, it is the, I think it is the maximum. So we will all gonna enter one here, one here, and another 255. So we're gonna enter also all one. And for 248, we'll have to compute if it from 1 to 4 8 16 24. So 1 2 4 8 16 32, 64 and 128. So 128 plus um, 32 plus 64, 128 plus 64 plus 32 plus 16 plus 8, is equals to 148, 248. So we will have to one from 128, then um 128, and then 64 will include 32, and then 16, 16, and then 8, and then all the other places will not be included, because it when we sum these, when we compute the total of these decimal, we will get 248, and so it will be all 0. Now we have the value of 0 here, so obviously we will just have to enter make it all 0. So for the prefix notation, um, what we have to do is to count the number of 1 here. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 and 21. So with the format with slash and 21. So let's check. So you have correctly converted the subnet mask to binary and prefix notation formats. please click new number to continue. So we will not click new number, we will move on to another activity. So we are here at chapter 8.1.4.5 activity. Determine the number of bits to borrow. So instructions: in this activity you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answers in binary, decimal, and prefix notation format in the fields provided. So now I know why the first activity is called basic, because it will be used here as a somehow another level, like higher level of that previous activity. So as you can see, we have prefix notation here and then the subnet mask. So we have to enter the subnet mask binary here. As you can see, it is example. So it has 111100. So when we are getting 25, we have to it's somehow reversed, like what we have to count is the zero, like where is um where is the 25, where what number will be nearest to 25. So we our count will start from like 2 4 6 8 10 12, like 3 6 9, uh 2 4 8 2 4 8 2 4 8 2 4 8 16. No, I forgot. So we will omit the one. So when we are counting zero, we will have to start from 2 4 8 16 and then 32, so on. So let's start. So as you can see, we have 25 here. So 2 4 8. So 2 4 8 16 and then 32. So 32 is the nearest number to 25. So we will stop here and then all the remaining digits will be 1. So 1 and then here will be 1 1 and then 1. And for the subnet mask, we will compute this um, like what we have done in the previous activity. We will summarize these um, decimals, but these binaries, and put it in the subnet mask. So it as you can see, it is all one, so it is obviously 255 point, so 255 point 255 point. So it is we will have to compute this like 1 2 4 8 16 32 32 64 and 128. So 32 plus 64, 32 plus 64 plus 128, it equals to 224. So 224. And for the prefix notation, we have the slash and then 1 2 3 4 5 6 7 8 16, then 24 24 25 and 6 27 27. I just remember that because it is a octet, bits will be um, all 8. So it will be all 8 bits. So let's move on to another um, number. We have given a high value here. So 1000, we will have to compute, we have to count 2, 4, 8, 16, 32, 32, 64, 128, 128 plus 8, 256, 1, 2, 2, 4, 8, 16, 32, 64, 128, 256, 256, and then 256 times 2, 512, 512 is now 512, then 1024. So 1024 is the nearest number to 1000. So we will stop here and the rest will be 1. Yeah. So for the subnet mask, we will have we'll just have to make this as 255.255 point will be this 1 2 4 8 1 2 1 2 4 8 16 1 2 4 8 16 32 plus 64 plus 128 252.0 because it is all zero. So the prefix notation is 8, 16, 17, 18, 19, 20, 21, 22, 22 slash 22. So for this number, I have to enter this because 75, 2, 4, 8, 16, 32, 64, and 128. 128, then the rest will be 1. So for the subnet mask, we have to enter, so 255, 255.255.255 point, so 1 2 4 6 1 2 4 8 16 32 64 and 128, and then for the prefix notation 24 25. So now let's move on to the second to the last number, which is number 10. So 2 4 8, and 16. So 16 is the nearest to 10, and then all will be 1, and then 1, 1, and 1. So 255.255 255.1124816 32 64 1 16 plus 32 plus 1 is 240 with the prefix notation of 24 25 26 27 29 28 24 25 27 28 28. So for the last host needed, we have 500. So 2 4 8 16 32 64 128 128 the 256 and the 500 512. So 512 is the nearest number to 100. So I have to enter 1 here, then 1, and then 1. So let's recount these. 1 2 4 8 16 1 2 4 8 16 32 64 64 128 128 128 256 um, and 512. So that's all one. So for the subnet mask in decimal, so 255.255.2 is it 255 2 4 1 2 254 254 point 0, and then it is 23. So so as you can see, we have answered it all, and let's see if we have got the correct answer. Let's check. So we have not correctly determined the it I have a mistake. So it is I have a typographical error. So it is 255. So if we check it, this one. Sorry for the typographical error. So yeah, we have answered correctly. You have correctly determined the subnet mask and entered it in binary, decimal, and prefix notation format. So now we're moving on to the last activity, which is the in chapter 8.1.5.8, which is practicing VLSN. Table 1 instructions. Table 1 uses regular subnetting to accommodate the network shown. So table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So for the activity here in chapter 8.1.5.8, which is practicing BSLM, we have to drag this um, appropriate IP addresses to this space provided here. So first subnets calculation, table 1 first subnets calculation. So calculate 50 per users per student per subnet. So new subnet mask decimal will be this 255.255.192, and then first prefix notation will be the 26, and then first full subnet range is the 192.168.5.0 dash, and then 192.168.5.63. Then the second full subnet is the 192.168.5.64-192.168.5.127, and then lastly the last full subnet range is the last set of IP address, which is 192.168.192-192.168.5.255. So let's check. So as you can see, we have correctly calculated the subnet. So that's all for today's video for chapter 8 in subnetting IP networks. So it's Alan Iverson Malbanan again. Thank you for watching the video.